Good afternoon, class. Thank you. You can sit down. All right, then today's lesson will be on similar solids and similar figures. And we will have to look at the exercise you were given in the previous lesson before we go on to that. Now, the exercise was on part variation, and you had to do questions 2 to 10. Okay, so it was on joint variation and part variation. Right, we'll look at question 2. It is known that P varies inversely as the square of Q. Corresponding pairs of values are shown in the following table. You have to find the value for T. Margaret, what is the value for T? You have no answer for that? What about Geno? The value for T? Anyone who's found the value for T? Yes, Rita.
T equals 16 over 9.
T equals 16 over 9. Okay, is there anyone who doesn't know how to get the value for T? Because I can explain. Okay. You are told P varies inversely as the square of Q, which means P is equal to K over Q squared. The value for P is T. The value for P is T when Q is 5. So T equals K over 5 squared, which is 25. From this equation, K is equal to 25T. Okay, you are also told that when P is T plus 1, Q is 4. So P is T plus 1. I'm substituting into this equation. K is not known. When Q is 4, then Q squared is 16. And K is equal to 16T plus 16. Okay, that is multiplying 16 on both sides of the equation, and we get 16 times T plus 1 is 16T plus 16. Now this equation says K is equal to 25T, and this one says K is equal to 16T plus 16. If this is equal to, if 25T is equal to K and 16T plus 16 is equal to K, then both of them are equal. They're the same. So therefore, we can say that 25T is equal to 16T plus 16. And then subtract 16T on both sides, I get 9T equals 16, and T is equal to 16 on 9. Clear? Okay, that's how we get the value for T, which is 16 on 9. All right, question 3. If y varies directly as x cubed and y is 25 when x is 10, calculate the value of y when x is 6. Esther? What's the value for y when x is 6?
Y equals 5.4.
Y equals 5.4. Did everyone get 5.4? Okay, the working out is there on the monitor. T varies, supposed to be y varies directly as x cubed. Y equals, that's supposed to be kx cubed. And then you substitute. All right. Again, y varies directly as x cubed. Y is equal to kx cubed, not kn cubed. Okay, is that one clear? Right, number 4. 4 says draw a neat sketch graph of the function y equals p on x, giving p the value which will make y equal to 4 when x is 3. Then state this value of p. How many of you did this question? Patrick, did you do this question? Yes? How many students were able to do this question? Put your hands up. What are you scared of? Okay, I'm going to do this one on the board to see if you've done it correctly. Y is equal to P on X. You are told to sketch the graph, but before you sketch, you actually need some values. Okay, you are to sketch it in such a way that when X is 3, Y is 4, which means the value for P will actually be 12. So the graph you are sketching is Y equals 12 on X. Okay, you should know Y is always on the vertical axis. X is always on the horizontal axis. We are going to do graphs and curves in detail this year and next year as well. But if I have some values here, 1, 2, 3, and 4, I get maybe 3, maybe 2, 4, 6, 8, 10, 12. 1, 2, 3, 4, 4, 6, 8. 1, 2, 3, 4, 2, 4, 6, 8, 10, okay, 12. When X is 1, if I substitute into here, I will get 12. When X is 2, Y is 6. When X is 3, Y is 4. We know that from the information given. And when X is 4, Y is 3. So the graph will be something like this. Okay, although it says you're not required to draw the graph accurately, but if you've never seen this type of graph before, you actually have to find the value for P first, which is 12, before you draw the graph. Okay, so that's what question 4 looks like. Is question 4 clear? All right, question 5. We did it as an example. Okay, let's just review the answers. Given that C is 74 when T is 1 and C is 34 when T is 2, we have to find the value of C when T is 3. Boromeo, what's the answer that we got?
C is equal to 62.
C is equal to 62. Okay, you'll have to look back to the example to be able to do that correctly. Number 6. A quantity P is the difference between two parts. The first part is constant and the second varies inversely as the square of Q. If P is 1 when Q is 2 and P is 6 when Q is 3, we have to find the positive value of Q when P is 7 and 3/4. Natasha, have you got an answer for us?
Q is 4.
Q is equal to 4. Very good. All of you got 4? Number 7. So for, again, number 6, Q is equal to 4. Number 7, it is given that Y varies inversely as the square of X plus 3. Y is 9 when X is 1. We have to find X when Y is 1. Megan?
X equals to negative 15 or 9.
Negative 15 or 9. Does anyone want to know how we got 9 or negative 15? Otherwise, if you all know, we won't bother. Huh? Do you want me to do it on the board? Yes? Right, number 7. Y varies inversely as the square of x plus 3. Y is equal to k over x plus 3 squared. All right, you are told that y is 9 when x is 1. So when x is 1, I will get 4 here, 4 squared. And k is equal to 16 times 9, which is 144. So the equation that we are substituting into is y equals 144 over x plus 3 squared. Then you are asked to find the possible values of x when y is 1. So 1 equals 144 over x plus 3 squared. So we are going to get x plus 3 squared equals 144. Okay, how did you solve the equation? What type of equation is x plus 3 squared equals 144? Jake? Quadratic equation. Okay, you tell me how you solved it. Did you expand x plus 3 and then move 144 to the left, make one side equal to 0, or you solved it some other way?
I expanded x plus 3 squared.
So you got x squared plus 6x plus 9 on one side.
Yes.
Okay. You can also find the square root of both sides. It's just that it's an easier way. Remember when you were solving using completing the square? Yeah, if you have a square on either side of the equation, then you just find the square root of this, which is x plus 3. But don't forget, the square root of 144 is plus or minus 12. So you get x plus 3 equals 12. That's where you get x equals 9, or x plus 3 equals negative 12, and that's where you get negative 15 from. If you solve like Jake said, you will still get the same answer because you will factorize in the end. Right, number 8. George, can you come and do number 8 on the board, please? And Agnes? No, Agnes said he had 10 last time. Garonamo, come and do number 10. Sorry, number 9. So, George, you come and do number 8. Garonamo, come and do number 9. square root of that. Sorry, the square. Ah. Oh yeah, it's okay, yeah, it's correct. Minus. Okay, from here, B is negative 16, therefore 68 is equal to A minus 16, or A plus negative 16. And that's why A is 84. Okay, the question is asking for an equation for V in terms of T. So the equation will be, okay, also here this one should be V varies as T plus T squared, and then you should then say V is equal to AT plus BT squared. Okay, so because we need an equation, we'll just have to replace that with A, which is 84, and B for negative 16. So the equation is V is equal to 84 minus 16, 84T minus 16T squared. Okay, that's the equation for part A. And then it says, use your equation to calculate the value of T when the body comes to rest. And the value for T. When the body comes to rest, what does it mean? It stops, okay? So V is equal to 0. So all we have to do is make V equal to 0 and solve for T. When we do that, we get T times 84 minus 16T. 1 will be T equals 0, that is at the start, so that you can't say that because it says that's when at the beginning, so that T equals 0 will not be, it will not be an answer. The other answer will be 84 minus 16, T equals 0. And then you just bring 84 to the other side and then solve for T. That's where you find T equals 84 over 16, which is, I think, 5.25. Okay, and since it's in seconds, t is equal to 5.25 seconds. Is that one understood by everybody? Okay. Sorry then. All right, part 1, that's the answer, and then part 2, 5.25 seconds. Okay, question 9, Garonamo. Good. Well done, Garonamo. The answer is 1,975 to the nearest whole number. 1,975.3, I think, 2 decimal place. Any questions on number 9? Very clear on the border. Okay. The last one, number 10. Anyone with an answer to question 10? Miriam.
D is equal to 0.16.
D is equal to 0.16. How many people got that same answer? Okay. All right, that was the exercise you were given to do for homework, questions 2 to 10. Is there anyone who would like me to explain one more question from that exercise? Number 10. Okay. E and H are connected so that E varies directly as H. And inversely as the square root of D. You are told E is 5 when H is 10. Sorry, it's supposed to be capital letter H. And D is 16. The square root of 16 is going to be 4. So I'm going to write 4 here. Okay, if I replace that by 16, I get 4. And 10K is equal to 20. Therefore, K is equal to 2. Okay. The equation that you are going to substitute into is E equals 2H over root D. Then you are asked to find the value of D when E is 20 and H is 4. So 20 equals 2 times H is 4. The square root of D. Okay, if I multiply by the square root of D on both sides, I will get the square root of D is equal to 2 times 4, which is 8. 8 divided by 20. And 8 divided by 20 is 0.4. And so D is the square of 0.4, which is 0.16. Point 1. All right, that's number 10. No more questions? Okay, we'll just start the new lesson and then we'll have to continue it next lesson. I'm just going to do the introduction part of that. Okay, it's supposed to be on similar figures and similar solids. You all know what similar figures are. It's the same as what you know about similar triangles. Okay, similar figures are those figures that have their corresponding sides proportional. And if we were doing geometry, then we would say their corresponding angles are also equal. Okay, like for instance, I've got two rectangles here, rectangle A and rectangle B. If these two figures are similar, then the ratio of the width here is the same as the ratio of the length here is the same as the ratio of the width. So 3:2 is the same as 6:4, or 6:4 is the same as 3:2. Or even if you compare the ratios here, 6:3 will be exactly the same as 4:1, which is the same as 2:1. Okay, that's on similar figures. You will notice for the area of this the area of this rectangle is 18 square centimeters, and the area of this rectangle B is 8. Now, if you find the ratio of the areas of rectangle A, the area of rectangle A to the area of rectangle B, all right, is 18:8, and it is 9:4. And if you compare the ratio of the length of A to B, whether it's the width or the length, you will find that the ratio of the length is 3:2, and the ratio of the area is 9:4. And to get, even without calculating the area, if you were told that these two rectangles are similar and the lengths are in the ratio 3:2, then their areas, without calculating the areas will be in the ratio 9:4. All you have to do is square 3, you get 9, and square 2, and you get 4. So you don't have to calculate the area of similar figures if you know their lengths, especially the ratios, because the ratios you'll have to square the ratio of their lengths to get the ratio of the areas. Okay, that's just a little bit on similar figures. You will not be given an exercise to do today. No homework. I'll have to complete the lesson on similar solids before you are given the exercise. So you have a break. The keyword to the pilot teacher is similar. Good afternoon, class. Good afternoon, Mrs. Thank you.